I also want to call specific attention to torques that are exerted by the gravitational force, because those come up a lot in everyday life as well as in physics problems. What exactly are the properties of the gravitational force when it comes to torque? I've kind of mentioned it here and there, but let me say it really carefully. So first of all, the force of gravity, well, as we already know, it has magnitude mg and direction downward. That we already know from earlier in the course. But where on the object does the gravitational force act? That is the current question. And the answer is that well, let's say it this way. For most practical situations, including everything we're going to do in this course, the gravitational force acts on the object's center of mass. So you can always treat the gravitational force like it's acting on the object's center. So the gravitational force won't cause the object to start rotating about its own center. It can only cause the object to start rotating about other points on the object other than its center. So when you need to include the gravitational force in a rotational problem, just put it at the object's center of mass pointing straight down. So let me give you an example of that. Very simple and very practical problem. We'll do this one here. So say I take this object and I release it from rest at a little bit of an angle. It falls over like that. Notice that this fall is actually a rotation. The base of the pen stayed stationary and it rotated like that as it fell over. So if you picture that rotation, there's an axis down here where the base of the pen is in contact with my hand, and the rest of it was rotating because it was falling. So let's study that problem for a second. Okay, so let's say there's the ground, and here is my pen at some angle like this. Okay, and I am considering it with an axis of rotation here at the base of the pen. So what are the forces acting on the pen? So you've got the gravitational force, which is acting up here and pointing straight downward. Make that a little bit smaller. The gravitational force acts on the center of the object, if this is a uniform object, and it points straight down. We're also going to have a normal force acting here, holding the object up. We could also have friction force at the surface. So which way would the friction force point? You might have to think about that for a couple minutes. The easiest way to think about which way is the friction force is, imagine if you did this experiment on a slippery surface, what would happen? Then the answer is the base would slip out from under it like that. The base would go in that direction. If my hand was really slippery, it would slide this way. So notice that it's sliding that way, away from the tip. So friction must be acting in the opposite direction. So the friction force would have to be acting this way. So those will be the forces acting on the pen. So this is mg, this is normal force, and this is friction force. And you'll notice that the normal force and the friction force right away don't exert any torque because they're acting at the axis of rotation. So there's only one force exerting a torque here, and that's the gravitational force. So the magnitude of the gravitational force here, so based on my drawing, the torque exerted by gravity would be negative because it's causing it to rotate clockwise. Then you're going to use this FTL idea. So FTL. This is probably maybe not the easiest way to do this problem actually, but I'll do it this way. So, oops, not FLL. Should have F, oops, there we go. FTL. So in this case, the gravitational force is not tangential. If I draw that circle that I want to visualize, the circle should be centered on the axis, something like that. And you'll notice the gravitational force is not tangent to that circle. So I should be visualizing a triangle, something like this. So the tangential component of the gravitational force would be this side here. So I haven't given you an angle in this problem, but like, let's say that you knew this angle here is theta. You would have Ft equals mg cosine of theta based on my drawing there. So you would put up here mg cosine theta. And then you also need L in there. Remember, L is the distance here from the axis to where the object is acting. So that would be the length of the pen divided by 2 in this case, because gravity acts on the middle of the pen. And that's how you would calculate the torque done by the gravitational force. So it's calculated exactly the same way that other torques are calculated. The only difference is you have to know where the gravitational force acts based on this conceptual idea that it's going to act on the object center of mass, and then make sure that that's cooked into how you're calculating the gravitational torque.